So far, the triangles we've been working with have been right triangles. Today, I want to talk about what happens when we have non-right triangles. And non-right triangles are what we call oblique triangles. So hopefully you remember from geometry, you probably had like ASA, angle, side angle, SAA, side angle, angle. So I just want to revisit that. I'll give you a picture from your book. So I'm hoping you've seen these things before. I'm not going to spend a lot of detail talking about them. Just keep in mind that the S stands for side, the A stands for angle. So, for example, an angle, side angle, ASA, case 1, means that you have two angles and between them is a side. The second one, SAA, means you have a side and then you have an angle, another angle. So it kind of goes in order. SSA is different from SAS, which are cases 2 and 3, because with SAS, you have an angle between the two sides, but with SSA, you have an angle that is not between the two sides. Actually, case 2 is our weird case, but we'll talk about that in just a minute. So you don't need to write down these cases, but I would like you to write down the law of sines, even if it's something that you know already. I think it's useful to have in your notes. So the law of sines is basically saying that sine of an angle over the side that's opposite that is equal to sine of a different angle over the side opposite to that, which is also equal to the sine of the third angle over the side that's opposite to that. And I'll draw an example of a triangle where this case holds. So like this would be angle A, this would be B, this would be C. Across from the angle A, that side is the little a. Across from angle B, that side is little b, and across from C, that side is little c. So you're going to find that if you try to use the law of sines for all of these situations, they're not going to work. So for case 1 and case 2, you will use the law of sines. However, for case 3 and case 4, those ones involve the law of cosines. That's going to be the thing that we do next. So today we'll focus on the first two cases. So first example, we have a triangle. I have given you two angles and a side. If you want to write out, this is AAS. So when I ask you to solve the triangle, that means that you need to find all angles and all sides. So we're halfway there. First thing that you're probably going to want to do is figure out this third angle. Keep in mind that in a triangle, the angles will always add up to 180. I think that's probably review. Hopefully you remember that. So you're just going to do 180 minus 40 plus 60, which does give us that final angle is 80 degrees. So it actually looked close to 90. It would have been nice if it was 90, then you could just use trig functions, but in this case, it's not, so we do have to use the law of sines. So when we use the law of sines, we are going to start by using the side that we know, which is that 4, and start with the angle that's across from that. So the angle across from that is the 40, so we're going to do sine of 40 degrees divided by 4. That's going to be equal to, and I don't care if you label what you label A, B, and C, it doesn't really matter. I'm going to call this one angle B, and this one side B, and I'll call the 80 angle C, and this one side C. So I'm going to do sine of 60. That's going to be over side B. Make sure that you have it across from the side that you use the side that corresponds with it, meaning the one across from it. So you can solve this out by, you can find the cross product. We get B times sine of 40 is equal to 4 times sine of 60. Use your calculator to solve that. Make sure your calculator is in degree mode. We use it for radians a lot, but in this case, it needs to be in degrees. So hopefully you get 3.464 on that side. Sine of 40 is 0.643. I would recommend that you keep these things in your calculator, and in your calculator you have the second answer button to get the exact value. So for this one, your B value, your side value is 5.389. This one we don't actually have any units or anything. It's not in degrees or anything like that, so please don't accidentally put degrees. But that's going to be this value right here. So we get 5.389. The other side, side C, we now have that, that angle C. So all we're going to do to find side C, we're still going to use sine of A over A. I don't recommend using the B side because it's a more complicated number. I just realized I put 40 here, but hopefully you figured out that I made that mistake there. Sorry about that. So I have sine of 40 over 4 is equal to sine of 80 over C. And I'm going to let you do this one on your own. Please do so. Hopefully you get 6.13. And looking at it, I got all of the sides, I got all the angles, so that means I'm done. So you'll find that if you have an angle, side angle, it's going to be pretty much the same process. So let's talk about the ambiguous case. So the ambiguous case we call SSA, or SSA is called the ambiguous case. The reason for that is because you can have one solution, you can have two solutions, or you can have no solutions. So you're just going to have to work out the problem to figure out which of the ones it is. And I'll talk about why that could actually happen, why you could have two solutions, and then you do occasionally have a no solution. I'll be completely honest, in real life applications, the ambiguous case doesn't really have a lot of them. Well, it does appear in math, so we will do it, but just know that we're not going to spend a lot of time focusing on this other than in this video. You might have one or two problems on it, but that's going to be it. So this one, we're solving the triangle. We have a side A equals 2, a side C equals 1, and the angle opposite of C is 50 degrees. So let's go ahead and draw that. So 50 degrees is going to look like that. And the side opposite of that is 1. So then we have, this is A, this is B, this side is 2. I would like you to try to set this up and work it out, see what you get. So when you set this up, you should get sine of 50 over 1 is equal to sine of A over 2. If you work this out, you get 2 sine of 50 is equal to sine of A. And I ended up getting 1.532 is equal to sine of A. So you might not realize it right now, but this is a bad sign. So we have sine of A is equal to 1.5. Sine cannot be any value greater than 1. So if you try to evaluate that using inverse sine function on your calculator, you will get an error. I got a domain error because the reason for that is because the value that you would get is out of our domain. So this one is a no solution. And I will tell you that I did draw this triangle not to scale. If I had drawn it to scale, it would look like that. And it would end up looking kind of like that. Like I would have a blank spot right here. So I did draw the triangle not to scale. But that is an impossible triangle. So if you get something like this, just know you could have a no solution. That does happen sometimes. So next example is I have an angle of 40 degrees, and the side opposite of that angle is 3, and then I have another side of 2. So this is side-side angle. I have two sides and the angle is not between them. You'll notice I do have an obtuse angle here. That's fine, that could happen. The side this is going to be C, so this is my A. This angle is B, it's opposite of the 2, and then the side opposite of the C is the side little c. So go ahead, I want you to set this up and see if you can find the rest of the sides and angles. So I hope you were able to do sine of 40 over 3 is equal to sine of B over 2. Keep in mind, it's hard to see from this picture, this B and this 2 are opposite each other, even though it almost looks like the 2 is opposite of the C, but actually it's not. You want your side to be opposite of an angle, not another side, so just be really careful about that. So on this one, you actually should be able to work it out. So on my left side, I got 0.214 is equal to sine of B over 2. And when I multiply both sides by 2, I get sine of B is equal to 0.429. That's actually an okay value because it is in the domain. I ended up getting that B is equal to 25.37 degrees. This is looking pretty good because I do have a legitimate angle that works, so I can see that it's not going to be a no solution one. So I want you guys on your own to see if you can find the other side and the other angle. And if you work these out, you hopefully find that angle C is 114.6 degrees and side C is 4.24-ish. So this last example is kind of a weird one because there's actually 2 ways that you can draw this triangle. So first of all, I'm just going to show you what it can look like. The first thing that you can get is you can get something that looks like that. The second thing that you can have is, this is not completely to scale, you can have a triangle that looks like this. Either of these would be a valid triangle for this particular situation, and depending on how you solve it, you might get a different answer. You're welcome to work this out on your own. I'll tell you right now that if you try it on your own, you would either get that your C, the final angle, is going to be either 95.1 degrees, and that would be this angle right here, or you can also get it, for this one, you can get it to be 14.9 degrees. So we're not going to go over this example. This one doesn't come up too often, but just in case you do see a problem like that, I just wanted to bring it to your attention that occasionally you do get 2 possible solutions.